We looked at the first derivative. Let's take a look at the second derivative in more detail. Notation. We now have very similar notation to the first derivative, but now it's y double dash f double dash x. When we write it in the d notation, it's d2, the function we're going to differentiate, dx2. On the top of the fraction, the 2 goes with the d, whereas on the bottom of the fraction, it goes with the thing it's with respect to. Don't make the mistake of thinking it's the first derivative squared, by the way. It's not a power. We're not saying it's a power. How do we find it? Well, we just simply differentiate a second time. Here's our function y. Find the first derivative, differentiate again, we get the second derivative. Ones like this involve a little bit more work because of course I've got to put this in index form first of all. In order to do this, chain rule, anarchy. Bring down the power, lower the power, diff the inside. There it is, nice and neat. I won't put it back in the third form because I'm going to find the second derivative, so let's do that. Now we've got to use a product rule. Write down the first, diff the second. Oh, to differentiate the second, I've got to use the chain rule. Bring down the power, lower the power, diff the inside, plus write down the second, and then diff the first, or at least that one's nice and easy. Differentiate x, you of course get 1. Tidying that one up. We do have some common factors there. Remember, whenever you're factorising, it's the lowest power you factorise out. So be careful with negatives. Negative 3 on 2 and negative a half. Well, it's the 3 on 2 is the lower one. What does that leave me with inside? Minus x squared plus 3. Now I'll put it back into third form, and there we are. We 3 over x squared plus 3 root x squared plus 3. So that's our second derivative.